Welcome once again in the class of water resource engineering. So we are learning the reservoirs. So far we have seen the capacity curves, then the uh, surveys for particular reservoirs. What are the types of surveys? So today we are going to see the site selection for the reservoir as well as the sedimentation. I am Mr. S. S. Ugle, Assistant Professor, Civil Engineering Department. So to begin with the reservoir sedimentation. Every year, river carries certain amount of the sediment load. The sediment particle try to settle down to the river bottom due to gravitational force, but may be kept in suspension due to upward currents in the turbulent flow, which may overcome in the gravity force or the gravity force. Due to these reasons, the river carries the fine sediment in suspension as suspended load and larger solid along the river bed as the bed load. When the silt laden water reaches a reservoir in the vicinity of the dam, the velocity and the turbulence are considerably reduced. The bigger suspended particle and most of the bed load were therefore get deposited in the head reaches the of the survivor. Fine particles may travel some more distance and may finally deposit further down in the reservoir. Some very fine particles may remain in suspension for much longer period in and may finally escape from the dam along with the water discharge through the sluiceway, turbine, spillway, etc. The deposition of the sediment in the reservoir is known as reservoir silting or the reservoir sedimentation. The deposition of the sediment will automatically reduce the water storing capacity of the reservoir. And if this process of deposition continues longer, a stage is likely to reach when the whole reservoir may get silted up and becomes useless. Moreover, with the passage of time, reservoir capacity will go on reducing. Thus, if today at the time of construction reservoir can store 10,000 cubic meter water, tomorrow, say after 5 years, it will be able to only store 8,000 cubic meters of water. Therefore, in order to see that capacity does not fall short of requirement during the design period, we must take care of this silt. So basically, it is a difficult problem for which economical solution is not yet been discovered, except by providing dead storage to accumulate or accommodate the deposits during the life of the dam. Disintegration, erosion, transportation, and sedimentation are the different stages leading to the silting of reservoir. The total volume of the silt likely to be deposited during the design period of life dam. So the approximately much volume is left unused, as we have seen, is known as the dead storage. The remainder of the knowing effective storage is known as the effective storage or the live storage. Dead storage generally varies between 15 to 25% of the total capacity. For example, Bhakra Nangal Dam has the gross capacity of the dam is 9,344 million cubic meter and dead storage of 2,054 million cubic meter. All the outlets fetching water from the reservoir are provided above the dead storage level. The importance of this silting can be understood by considering the following example. That is, let the total capacity of the reservoir is of 13 million cubic meter and provision of dead storage will be 6 million cubic meter. Let the average volume of the sediment deposition will be 0.15 million cubic meter per year. Then it is evident that the dead storage will be filled up in 40 years. Then the total storage is about 200 years. Hence, the usefulness of the reservoir would start reducing after 40 years, and after 200 years, it would be nothing but a collection of sand and sediments with no water in it, provided the siltation rate remains constant at 0.15 million cubic meter per year. So, this is the useful life of the particular reservoir. Now, so here you can see this is the conceptual gauge. So this delta formation is there, and this is where this turbulent inflow enters. Here is the turbulent flow into. This is the here the floating debris is there, and this water is recycling over there. These are the density currents, and this is the dead storage, and this bottom sluice has been provided above this, and this is the live storage, and this is the dead storage. This is the clear water circulation induced by the density currents, because obviously the incoming water has the more density due to all these particles, and clear water has the less, so it is moving upward direction. Now, so as I told you, in the reservoir the coarser sediments settle down along the bottom of the reservoir, and the muddy flow approaches the reservoir, while the finer sediment usually remains in suspension and move in the separate layer than the clear reservoir water, as shown in this figure. This layer of water containing the fine sediment moves below the upper clearer reservoir water as density currents. Since its density is slightly more than the density of main body of the reservoir water, because because of their density difference, the water of the density current does not mix easily with the reservoir water and maintain its identity for the considerable time. The density current can thus be removed through the dam sluiceway if they are located properly and at the level of the density currents. A lot of sedimentation load can thus passed out through the reservoir if it is possible to locate the dam outlets and the sluiceway in such a fashion as the vent out the density currents. The trap efficiency of reservoir is thus decrease about 2 to 10%, and if it is possible to vent such density currents through the outlets and the sluiceways of the dams. Now the efficiency. So this is again the important term. Efficiency is defined as the percentage of the sediment deposited in the reservoir, even in spite of taking precautions and measures to control its deposition. So what is the efficiency? It is the ratio of the total sediment deposited in the reservoir divided by total sediment flowing in the water. So most of the reservoir trap 95 to 100% of the sediment load flowing into them, even if the various feasible seed control measures are adopted. It not been possible to reduce the trap efficiency below 90% or so. So what are the reasons of or causes of sedimentation? So it is the nature of the soil in catchment area. If soil is loose and it can erode easily, then uh, obviously there will be a more sedimentation in this particular the reservoir or the dam. Then the topography of the catchment area. If the topography will help to move the suspended particle, then again the erosion will be more. Then the cultivation in catchment area and the vegetation cover in the catchment area. So if the vegetation is more than obviously this silting is less, because that roots hold the uh, soil or the loose particles, and the intensity of rainfall in catchment area. If the intensity of more, then the erosion is also more, and it, because of this, also the this sedimentation is also more. I would love to mention one thing, that is about the Koyna Dam. So it has located in such a great place or great location. It has so much less sedimentation in this that particular dam. So I came across I have visited to the Koyna Dam, and that time, fortunately, my one of my friends is was working there, so he told about it, that it is located in such a place that it don't have that much of problem of sedimentation in this particular uh, Koyna Dam. So now the sedimentation management. So what can be done to manage the sedimentation? So basically, there are two approaches, that is pre-constructing measures and post-constructing measures. So maximum efforts should be should water should be released so much so that less sedimentation should retain in reservoir. The following options are catchment vegetation, then construction of coffer dams, that is watertight enclosures from pumped dry to permit the construction work below the waterline or low height barriers. Then the flushing and desilting of the sedimentation and low level outlets or sedimentation sluices. In addition to this, there are few more measures, that is pre-construction measures. So first is the selection of dam site. As I have told you in case of Koyana Dam, so silting depending upon the amount of erosion from the catchment. If the catchment is less erodible, then silting will be less. Hence, the silting can be reduced by choosing the reservoir site in such a way that to exclude the runoff from the easily erodible catchment. Then construction of dam in stages. The design capacity plays an important role in the silting of the reservoir. When the storage capacity is much less than the average runoff entering the reservoir, the large amount of water gets out of the reservoir, thereby reducing the silting rate as compared to the what it would be if the entire water will be retained or the stored. Therefore, the life of reservoir can be prolonged by constructing the dam in stages. In other words, first of all, dam should be built lower and raised subsequently when some of its capacity gets silted. So we have so many examples. That is, Almaty Dam has been raised. Again, this Koina Dam also has been raised because we need the actually more capacity. So that things can be done. In construction of check dams, as I have told you earlier, the sedimentation can inflow controlled by the building check dams across the river streams, contributing the major sediment load. These are smaller dams and trap large amount of coarser sediment. So it is, but they are quite expensive. Then the vegetation screens are there. This is based on the principle that vegetation trap large amount of sediment. The vegetation growth is therefore promoted at the entrance of the reservoir as well as in the catchment. These vegetation covers through which the fluid waters have to pass. Therefore, entering the reservoir are known as vegetation screen, and there are cheap and good method of silt control. Basically, in case of Koyana Dam vicinity, we have the big what we can say jungle like area, and it is preserved also. So obviously we have this advantage that this obviously the vegetation screen is automatically there and it holds the particular soil in that particular area. Then construction of under sluices in the dam is provided with the opening at the base so as to remove more silted water on the downstream side. The sediment concentration will be more at the some level than at others. Therefore, sluice located at this level of higher sedimentation concentration, the method is itself not sufficient because the water digs out channel behind the sluice for movement and leaves the most of the sediment undisturbed. Therefore, it is simultaneously supplemented with the mechanical losing and scouring of the neighboring sediments in order to increase the effectiveness. But provide large sluice near the bottom of the dam is again the structural problem that we cannot provide a big size of these sluices at the dam. So use of this method is limited. Then the post construction measures. First is the removal of post flood water. The sediment content increases just after the floods. Therefore, the attempt is generally made not to collect this water. Hence, the efforts should be made to remove the water entering into the reservoir at this time. Then mechanical steering of sediments. So the deposit sediment is caught and disturbed by the mechanical means so as to keep in the moving state and thus help in the pushing it towards sluices. Then the erosion control and soil conservation. It includes the general method in which adapted to reduce the erosion of soil and make it more and more stable. This method is more effective method for the controlling of siltation, because when the soil erosion is reduced, the sedimentation problem is reduced automatically. But the method of treating the catchment in the order to minimize the erosion is very costly. Here you can see some pictures of catchment vegetations. Then wooden barriers has to be have provided. So here this particular silt is trapped, and then water flows into the particular catchment area or the reservoir. And here stepped watershed sediment control has been done, that water coming through these steps, and because of this reduced velocity, the sediment or sedimented this silt used to settle over on these beds. Then this is the flushing of sediment from the reservoir. So you can see from this bottom, this debris and all the silt contained water has been discharged, and this is the mechanical desilting of the reservoir. So this can be sucked and throwing out from the reservoir. This is sediment sluicing. What are the criteria for the selection site of reservoir? So obviously large storage capacity should be available. Then valley should be narrow, and length of the dam should be constructed is less. So obviously there will be a less area should be coming under the dam construction, so that it will be economical. Then water tightness of reservoir should be necessary. Then good hydrological condition should be there. Then reservoir should be deep. Then small submerged area should be there, because if the area submerged area is more, then obviously there will problem of relocation of the people, or the whatever damage has been done to the environmental, that is also we need to think. Then obviously low silt inflow. Then uh, no objectionable mineral should be there, so that the waters can't get polluted due to because of that mineral, and no adverse effect will be there on the health of the people those are using water from that particular area. Then uh, the real estate cost should be low, because if area is developed and that is going under this dam site, so that is not of the use. And whether when acquiring the land also, we need to take care of all these things. Still we can see there are so many problems of this uh, people those are displaced by the construction of dam, and this site should be easily accessible. So these are the site selecting criteria for the reservoirs. This is all for the reservoirs. Thank you.